How do I find out if the locus is a half-line ray? Consider the example. The point P represents the variable complex number z on an Argand diagram. Sketch and describe the locus of P given that argument of z plus 2 minus I is equivalent to 2 pi on 3. Given that the argument of z plus 2 minus I is equivalent to 2 pi on 3 and z has the form of x plus iy, then the argument of x plus 2 plus I into y minus 1 would be equivalent to 2 pi on 3. So we get the tan inverse of y minus 1 over x plus 2 is equal to 2 pi on 3. We can then simplify and make y the subject of the formula to get the Cartesian equation of the line y equal to negative root 3x plus 1 minus 2 root 3. However, there is a restriction on the line. Let us use our knowledge of vectors and use an Argand diagram to understand why we have a restriction. Since z plus 2 minus I can be written as z minus 2 plus I, then we can use our knowledge of vectors to rewrite the argument as the vector BA equal to 2 pi on 3. You can see that if OA is equal to OB, then BA will be equal to 0. Let us draw this on an Argand diagram to see the restriction. First, we draw the complex number minus 2 plus I, and at the endpoint we draw an open circle. We can label it B. This circle is the starting point of the line that will represent the locus. Next, draw a line at an angle of 2 pi on 3 to the horizontal that starts at the point labeled B. That line will represent the locus of Z. Z can be any complex number that starts at O and ends on that line. For example, the complex number OA. So, if the argument of z minus z1 is equal to theta, then the locus of z is a half-line ray that starts at z1 but does not include z1.